Hello everyone, good evening. We are trying to solve the past year questions from the AP Calculus exam. These are the open response questions, and as you can see, all of these questions are a bit of storytelling type, right? We call these comprehension questions, where a set of instructions will be given to you, a function will be given to you, just like the previous question, right? There we use the Newton's laws of cooling or basic calculus to solve a question that was based on Newton's law of cooling, right? Here this question is based on a bit of concepts in physics as well as mathematics. So a velocity function is given to us for a particle that is supposed to be moving along the x-axis. Now if a particle is supposed to be moving along the x-axis, we will assume that the particle is moving along the positive x-axis. Why do we assume it? Because if it would have moved in the opposite direction, the question text would have said that the particle is moving along negative x-axis. Since it does not say so, we will assume that it is moving along the positive direction. Alright. Now the velocity function is given to be a logarithmic function minus a linear function. Now this function is quite tricky to solve if we do it manually, but instead, well, you can do it via a graphical calculator, right? You can plot ln t square minus 4t plus 5 and you can plot 0.2t. You can check their point of intersection and that will give you a solution. Instead of the graphical way, I will teach you a numerical way so that you can handle these type of questions even with a normal calculator rather than a graphical calculator. Alright, graphical calculator is allowed, but there is no problem or harm in learning a new method, right? So we will solve this via the numerical method known as Newton-Raphson method. Now this method will be taught to you in a numerical methods class or a numerical analysis class, which is a bit higher in mathematics, but this method uses the techniques of normal 11th 12th standard calculus. Alright, by that I mean the AP calculus level. It will be using all the concepts from those chapters only. Now the method that I will be teaching to you is quite accurate, so maybe 3 or 4 steps will give you the correct answer, and for that we will be just needing the function and its derivative. Now if a velocity function is given to you and you are having to use the derivative, you will be ending up with an acceleration function. Now as we can see that option B contains some questions relating to the acceleration of the object, so we are going to use the acceleration anyway. So let us first calculate the derivative and then we will find the particular position at which the body is at rest. Before we start this particular question, I would just like to inform you that this function is a velocity function, which means it can give you negative values. Alright, if you are supposed to calculate the speed at any point, do make sure that you are taking the modulus of the function. That would give you the speed with excluding the direction, which could be negative or positive. Alright, now let us solve it by the numerical method. Now the Newton-Raphson method, it's quite funny. A method that leads you to your solution quite quickly. It's nice for mathematicians. It works very well. Now v of t is given to be this function, right? I am not writing it down. Basically we have to find tr such that velocity of tr is 0, right? And tr belongs to the interval of 0, 2. So let us calculate the derivative first. V dash t, that is the acceleration function a of t, that will be equal to first the reciprocal of the entire thing because it's under ln, and then the chain rule applies, so 2t minus 4, 0.2t is linear, so 0.2. Alright, that is the acceleration function or the derivative of the velocity function. Now to start the Newton-Raphson iteration solution, we would need an initial guess. So assume I messed up the spelling. Assume tr equal to the initial guess t0 equal to 1. Why am I assuming this to be 1? Why not 1.1? Why not 1.2? Because I am looking into the interval of 0 to 2, right? The most common value between 0 and 2 is 1. The sum will work with 1.2, the sum will work with 1.5, the sum may also work with 1.9. It all depends upon the value you choose. I am choosing 1, so if you have to practice this method, you can check the calculations with me and then match your own values. Alright, and if you want to experiment with a different seed value or initial value, after we have reached the particular answer that we want, you can do one more separate set of calculations. Obviously not in the exam, but as a practice you can use a different seed value and check if your calculations are yielding the same result. Okay, some assumptions, if far away from the truth, will take larger number of iterations to get solved, and if by chance you choose a starting value that is closer to the original answer, then you will get your answer in 2 or 3 steps. Alright. Anyway, we will be doing 3 steps because this method spits out the answer quite fast, and 3 steps are usually more than enough to get you to the accuracy that has been asked of this question, which is 3 decimal places. So all of the calculations we will be doing will showcase 4 decimal places, and at the end we will round it off to 3 decimal places. Okay, so let us begin. Now before beginning, let me give you the formula. The formula is T of n plus 1 equal to Tn minus V of Tn divided by V dashed of Tn. Now we will be beginning with n equal to 0. At n equal to 0, T1, which is the first approximation, is equal to T0 minus V of T0 divided by V dash of T0. Now we have V of T and V dash T, right? So we can just plug in the value. So T0 is 1 and it will be 1 minus, I'll have to give you the values because if I start calculating them now, first of all it will take a lot of time and it will not be an enjoyable viewing experience. Okay, so I'll just give you the values. V of T0 turns out to be, if I do the calculation, 0.4931. Alright, and V dash of T0 turns out to be minus 1.2. So if I do this calculation, I end up with the first approximation T1, which is 1.4109. Use this T1 at n equal to 1. This time we will get T2. This is equal to T1 minus V of T1 divided by V dash of T1. This will be equal to T1, which is 1.4109 minus V of T1 this time turns out to be, I'll give you the values again, 0.0154, and we divided by minus 1.0748. These are the values that are obtained from the calculator, and that gives us a second approximation of 1.4252. Alright, already I think we are closer to the answer, because see, from 1, the initial assumption was 1, we improved our solution to 1.41 something, then we improved that to 1.42. so already you can see that the changes are taking place in the second place after decimal, right? The first 2 places are fixed, they will be 1.4. so let us check n equal to 2 now. That would give us third approximation, T3 equal to T2 minus V of T2 divided by V dash of T2. Now this is equal to 1.4252 minus, now this value V of T2 would give us minus 0.00006. Alright, so very small value, and V dash of T2 will give you 1.0650 minus 1.0650. Alright, now this value will turn out to be 1.4258. Already you can see we have reached quite a high level of accuracy, because from T2 to T3 the only change that occurred was in the last decimal place. Now that will get eliminated anyway when we round off, right? So I'll stop my iterations here. If you want, you can check one more iteration by yourself, but for the exam purposes this is enough. So that means V of TR is approximately equal to V of, sorry I wrote it down wrong, V of T3, which is 1.4258 seconds approximated to 1.426. Now 2 values are allowed for this particular question, 1.425 and 426. It depends on the method that you have used. So both of these values are classified to be the correct answer, and that will be your final solution for this. Is the particle moving to the right or to the left? So that we have to calculate. Now we have the value of V of TR is greater than 0, right? Let us calculate V of T0. So V of T0 at, I mean not T0 but T at 0. So V of T equals to 0, that would give us ln 5, right, which is positive, and then V of TR, that is equal to, okay, if we put this value 1.426, you can calculate the value, okay, that will be 0, right? because that is what we had to calculate. Here we are actually not getting the value of v, isn't it? We are getting the value of t. So I'll correct this. Alright, now that value will be 0, which means we are moving from a higher velocity to 0. So we are not going into the negatives, right? So that means from 0 the velocity will be positive, right? Which means the particle is moving along the x-axis. No negatives means no change in direction. So here v of t is greater than 0, which means particle moves towards the right. Alright, hopefully the explanation suits you all. And with that, we will move on to subpart B. Find the acceleration of the particle at t equal to 1.5. We have already done half of this problem. We have v dash t, we would just need to calculate v dash of 1.5. Now this is just putting a value in the function, right? I am not going to give you that calculation, and if you put that value, you will basically get a of 1.5, which is minus 1. Alright, so this means the acceleration of the particle at time t equals to 1.5 is minus 1. So if there is an acceleration which is negative, which means the particle is slowing down, which is congruent with our observations, right? Because v at 0 was ln5 and v at tr was at rest. So from 0 to tr, the particle is slowly coming to rest, which means acceleration is working in the opposite direction. Alright, so what else do you have to do? Show the setup. Setup has been shown, right? Here you can write it a bit more in details by showing the derivative here also. Okay, so that will give you full credits. Is the speed of the particle increasing or decreasing at t equals to 1.5? So at t equals to 1.5, is the speed increasing or decreasing? We would have to calculate v of 1.5. So v of 1.5, they are asking us the speed, right? So we would calculate modulus of v 1.5. Modulus of v 1.5 will turn out to be 0.0769. Or you can just approximate it like this, 3 digits, which is greater than 0. Alright, so this means the speed of the particle is increasing, alright, at time t equal to 1.5. Okay, now why does this happen? Because at time tr equal to 1.4, the particle goes to rest. So the particle has some velocity, right, and it slows down to rest at 1.4, but at 1.5 the acceleration is too much now, so it starts moving in the opposite direction. That is why the speed is increasing. Alright, so whenever you are solving these problems, try to visualize it also, so that will give you the complete picture, as well as point out to you any fallacies in values if you are getting them. Alright, so this section is done. We have all of our reasonings. I have not written it down, but hopefully you can discern it from the explanation that I gave you. Okay, now C part. C part says the position of the particle at time t is xt, and its position at time t equals to 1 is x1 equals to minus 3. Find the position of the particle at t equals to 4. Now if we are to calculate the position from velocity, you know how to get it, right? We would just have to integrate it. So x4 would be x1 plus the integration of 1 to 4, because the position at time 1 is given, right? So from 1 to 4 you integrate vt dt. Alright, that's it. The position of the particle t is xt, of course. T equal to 1 is given, x1 is given, fine. So we can put the value. We would have to calculate t4, which is at x4, right? So x4 is x1. From 1 we would have to calculate the integration from 1 to 4. Alright, 1 is already given here. Now again numerical methods here, so you can do this via the calculator directly. This will give you minus 3. x1 is minus 3, that is not calculated via the calculator, that is given in the question, and the value here will turn out to be 0.1971. Alright, which you can approximate up to 3 decimal places to be minus 2.8. 0.80. Okay, so this means here the position of the particle being negative means it's beyond 0. Alright, so it was moving in the positive direction, now the acceleration has kicked in and now it has started moving in the negative direction. Alright, and where is it at time t equals to 4? It's at minus 2.8. Alright, at time t equals to 0 it was at ln 5, at time t equals to 1.4 it was at rest. Okay, we don't know what position that was in, we have to put that value in x and check. Alright, so it was at rest there, and then as the acceleration, negative acceleration started kicking in, the particle got pushed towards, instead of moving forward it is getting pushed backwards. So at t equal to 1.4 it was at rest, at t equal to 1.5 we calculated from the last problem, its velocity was, its speed was increasing, so it was increasingly moving towards the negative side of the x-axis, and at time t equal to 4 it has already reached minus 2.8 on the x-axis. Alright, so let us look at question D. Find the total distance traveled over 1 to 4. Again, simple integration. We have to calculate the total distance from 1 to 4, and since this is the distance not the displacement, remember whenever we are calculating the integration of velocity, that will give us displacement, because velocity being a vector quantity, the direction is not getting eliminated. Alright, so instead of the direct integration we would just calculate the modulus of the integration. Alright, so we would do 1 to 4 vt dt and then take the modulus. Alright, so again easy calculations via the calculator, this will give you 0.958. Alright, now this value 0.958 means that the total distance traveled by the particle over 1 to 4 units of time is 0.958. Now this is getting traveled in the opposite direction. Alright, how do we know this? From the previous subpart. Alright, so I hope you got the answers to this question as well as the gist of what is happening to the particle in question. Let me reiterate the entire thing to you so that you get the scenario in detail. There was a particle that was moving along the positive x-axis with a velocity equation that is given here. Okay, now at time t equals to 0 its velocity was ln 5. Okay, you can calculate the value, whatever it is, it will be positive. It had some positive velocity at time t equals to 0. Okay, at time t equals to 1.426 the particle halts to rest. This is because acceleration is acting on the particle in the opposite direction. So a particle is moving, right, at time t equals to 0 it has a speed, slowly the speed is getting eroded because a negative acceleration is working against it. At time t equals to 1.4 it is at rest. That is what we obtain in subpart A. Alright, now in subpart B we are calculating the acceleration and we are having to calculate the speed of the particle also at 1.5. So at 1.4 the particle is at rest, at 1.5 the acceleration starts pushing it backwards. Okay, now at 1.5 the particle has increasing velocity or increasing speed, that will be a much better answer, increasing speed in the opposite direction. So particle was moving, it slowly ground to rest because acceleration is acting in the opposite direction. Now that acceleration changes the direction of the object and it starts increasing its speed at time equal to 1.5. In the next part we calculate where the particle is at t equals to 4. So at 1.5 it was moving at an increasing speed in the opposite direction, so it would have gone to the negative direction obviously. So from part C we obtain that at time t equals to 4 the particle is now at minus 2.8. that is what the value we obtained, right? Let us recheck it. Yeah, minus 2.8. so it is at x equal to minus 2.8. so whatever distance it had covered in the first 1.4 seconds before coming to rest has been recovered and it has moved in the negative direction. And in part D we obtain that it has moved a total of 0.958 units in that time at which it moved to x equal to minus 2.8. so the distance that it covered was 0.958. Alright, so I hope you get an idea of the dynamics of the particle, of its life story so as to speak. And again this question was not at all complicated, it just focused on the basics of speed, distance, time, velocity, displacement, acceleration. You would have to know what each of these quantities represent, what the integrations and differentiations for each of these quantities mean, and how do you get the magnitude out of these vector quantities without impacting its direction. Okay, so speed from velocity, distance from displacement, etc. All right, I hope you have understood this entire problem. I have taught you a new method in the Newton-Raphson equation. It's quite easy to be solved by the calculator. You just need to program in the functions, and then you can keep changing the arguments again and again. All right, this is one of the most easiest techniques of doing it by the calculator. You can just press equal to 3 times and you would get 3 values. All right, so make sure that you practice this. I have used 1 as an approximation. You can try it with 1.5, you can try it with 2. The farther your approximation will be, because we now know in hindsight that our approximation from 1 ended up at 1.426. So if you start with 1.4, you will probably get your answer in 2 steps. Okay, and if you start at t equals to say 100, you will take maybe 3 or maybe 8 or 9 steps to reach the correct value. But this method is converging very fast, so you would not have to spend much time on it anyway. All right, okay, so I'll end this video here. We will study the next question in our subsequent video, where we will break it down as we do it with this question. All right, now if you do have any questions relating to this, because I taught you quite a lot of stuff and we talked about the particle in detail, do make sure to contact the number that is given just below my face panel. All right, you drop a WhatsApp there with your query. We will be able to assist you with this course, as well as any problems or any exams that you face which bases its questions of this type of syllabus. All right, the EP calculus syllabus. You will get all of that help. Just make sure you contact us in the number given. All right, if you do have any suggestions, feedback, etc. on this video itself, you can use the comment section on YouTube. Our details are also mentioned in the description of that video, so you can contact us via that also. All right, I'll end this video here. Thank you all for joining. I hope you learned something, and do let us know if you have any questions. All right, I will see you all in the next one, and in the meantime, take care.